Woohoo! I wanted to check in very briefly and talk about the difference between x squared and 2 to the x. So here you'll see I've got Desmos up. Desmos, again, desmos.com is a graphing calculator, really wonderful, absolutely free. You can get it as a web app or as an app on your smartphone or smart device. And I've just typed in two different equations here. I've got x squared, which is a parabola, a quadratic. And you can see that's in red. So we can see here's what you would expect to see from a parabola. And then in the blue, I've got 2 to the x. Now notice that the difference here is that in the red equation, I've got x as the base. And in the blue equation, I've got x as the exponent. And so you can see it's a really different type of graph. On the right side, over here in quadrant 1, they're actually pretty close. They're in fact right in here. They look almost identical. I keep flirting with that number. Notice that point has been highlighted for us. Desmos knows that we'd be interested in where they intersect. They intersect at the values of x equals 2 and y equals 4. So if you plug in x equals 2 here, you get 2 squared is 4. If you plug in 2 here, you get 2 squared is 4. Ta-da! The other thing you'll notice is there are a couple other points that are highlighted. The point 0, 1, which only exists on the blue curve on the exponential function. And then another intersection, and this one is not nearly as nice, over here in quadrant 2, where x is negative, between negative 0.7 and 0.8, and y ends up being around positive 1/2. And so these are the two intersection points. I've got an intercept here for the blue one, the blue line, the exponential. And of course, the parabola is going to go through the origin 0, 0. So how are they different? Well, you'll notice that a parabola has symmetry around or about the y-axis. So it's the same thing on the left side that you see on the right side. Does the exponential function, the blue one, have symmetry? No, it does not have symmetry, but you'll notice they both share one thing, which is neither of them goes negative. The parabola kind of flirts with negative right there. It goes to the origin, then it pops back up. The exponential, I know it's hard to tell over here, but you'll notice that it isn't actually on 0. It's just very, very small. So hard for Desmos to graph in a way that we can see, but it's not actually at 0. And in fact, an exponential function will never intersect this x-axis, this one. I can do things to it. I can move it around, obviously. I can use a transformation by adding values or subtracting values so that we could actually move the graph around. So it would intersect the x-axis, but in this pure form, so if it looks like y equals some value to the x power, it will not go past through the x-axis into the third or fourth quadrant, and neither will a parabola. We can look at, this is the easiest one to look at, but if we want to look at what happens when I change this to x cubed and 3 to the x. So now I've muddied the water. The x cubed is a cubic, and you may not have studied these, but basically a cubic looks like a very, very stretched out parabola, except it's like it broke right here, and the part that was going to go up like this flipped down, and we get a different kind of symmetry. So the x cubed is positive when x is positive, and negative when x is negative. That's the red guy. That's right here. That's the cubic. And here, my exponential function looks a lot like, let me show, y equals 2 raised to the x. You can see, or maybe you can't, you can kind of see, I'm going to drag it around so we've got some space to look at it. This is the great thing about Desmos. And I know not everyone thinks that it's fun necessarily to play with a graphing calculator, but it is a really excellent way to get comfortable with a lot of graphs, because you could just say, well, what happens if I plug in, I don't know, y equals 100 to x to the x power? And the answer is that's what happens. So you can see I've got my 2 to the x, I've got my 3 to the x, and I've got my 100 to the x. Here is the 2 to the x in green, the 3 to the x in blue, and the 100 to the x in purple. And you can see they all share that same shape. And if I come over here, oh, Desmos. Desmos just failed us. It's telling me that the intersection is at 0. Is it at 0? No, it's just such a small number that Desmos is having trouble with it. So let me come over here. Are you going to be able to? No. So it's not going to be able to give me enough detail. There we go. Okay, so if I really get a close-up look, Desmos is like, okay, you're right. It's not exactly 0. So let me pull out a bit here so you can see. So what's going to happen with exponentials is they're going to head down like this if we go backwards, and they're going to get really, really, really close to the x-axis, but they're not actually going to intersect it. Now, what is the name for that? Let's do it Dora the Explorer style. I'll listen and I'll say, you're right. You're absolutely right. That's called an asymptote. This is an asymptote. It's asymptotic, which means it gets really, 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 really close. It looks like they all smash down here on the x-axis, but they're not actually touching. They're just getting closer and closer forever, which is an interesting way to think about infinity. Like imagine trying to get closer and closer and closer to something, but never actually getting there. It's kind of a brain twister there. So, and I'm going to go ahead and get rid of the cubic because that's not really helping us. These are all the exponentials. And what I'd like to do is ask you, since I've got your attention here, I'm assuming if you're still watching, I appreciate it. Awesome. Can you think of a way to get the exponential to go the other direction? So instead of starting out really, really, really small and going boom up into the stratosphere, is there a way to get something to start up here in the very large and come down like that? And if you have studied exponential functions in another class, then you may know that the way to do that is to set up a fraction. So I could have written this 1/2, or I could have written it as 0.5. It's up to you whether you want to use the fraction or the decimal. Desmos will work with both. That's the cool part about it. Notice that if can I turn these guys off? Oh, Desmos is so awesome. Look at that, I could turn those off so we can just focus. So here's 1/2 to the x, and here's 2 to the x. Notice they head in different directions. Why is that? Well, because 2 to the x and 1/2 to the x are looking at different, the opposite value of x. Another way to write 1/2 to the x is to write 2 to the opposite of x. These two, 4 and 5, are exactly the same graph. 1/2 to the x is just 1/2, right? That's 2 to the -1. So this becomes 2 to the opposite of x. So this is the opposite of, so when I plug in -2, this function is actually seeing +2 because it's got that extra minus in there. But when I'm plugging in -2 to the green one, to the 2 to the x, it's actually seeing the -2. When I plug in 2, the green one is seeing just plain old 2, but the red one, this guy, if I plug in 2, is seeing a -2. So that was my very brief, hopefully helpful, sort of review refresher on what graphs of exponential functions look like. And we'll be using these a lot in chapter 5 and chapter 6. So woohoo, math on, know that you're awesome. Have a great day. You guys are wonderful and amazing. And I'm stalling because I don't know how to stop the recording. Here we go. Woohoo. Have a great day. Math on.